This one's for you, Justin. It's rectify here, and I just threw together a quick and easy, cheap and greasy version of the Tesla hairpin circuit, which is basically a closed loop that will still run the load. It's a closed loop all the way around the output, with two capacitors coming out of a spark gap being powered by an oscillator. In my case, I'm using a Flyback transformer and a Flyback driver. I know it's pretty ugly looking, but it was custom because that's a Russian transistor there. I'm running the entirety off of a lithium-ion 3-cell focus, 11.1 nominal volt. One of my RC airplane batteries. It puts out some nice currents. So there we go. We got basically in parallel coming out of the transformer. We have the spark gap. I have it set to about 3/8 of an inch, and from each side of the spark gap, we're going to a couple of metal capacitors, some high voltage capacitors. They're the same, even though they're different sizes. They're made by different manufacturers. They're exactly the same ratings. I think they're like 1700 volts, 0.8 microfarad or something like that. Alright, and then it just goes to a closed loop all the way around. I've got multiple nails in there at every other point, just like Tesla did in his diagram. Those are my tap-in points to find resonance. Here, I have 110 volt, 30 watt microwave light bulb, right? 30 watt, 110 volt. I have it going across this closed loop. Okay. Here's Tesla's drawings of this. Okay. So here we go. I'm going to fire this up, and we'll show you what's going on here. Alright, so we've got ignition here. It's getting hot. Real power. Now watch this. I can touch this lead. I can touch this lead. I can touch both leads at the same time. Nothing's happening, right? Nothing. I'm touching them both. Closed loop. Running this. Watch this. I'll prove it's real power. Watch this. Real power. Because I can touch it. And I can touch this. Nothing. It's a different kind of power. Tesla shit. Right? Let's put this back on. Watch this light up. Spark gap's flying. Check the heat of the transistor. We're good. Now, I'm going to take a bucket of water. I'm going to hand this to my wife so she can film. Here we go. I don't want to cut the camera. I'll put this in this bucket. I'm going to add water. Now I'm going to put my hand in there with both electrodes. It's still lit. How's this working, guys? We've been suppressed by so much knowledge, it's sickening. Okay? So that's in water. Now I'm going to shut the circuit off because it's kind of dying. Let the transistor cool a little. And I'm going to attach another load up here. It's going to be a 110 volt LED. So we'll have incandescent 110 volt 30 watt along with the 110 volt Lights of America 2 watt. So we'll attach that at the top node up here as Tesla would. And I'll get back to you in a second, and I'll keep this in the water, and I will dump that one in the water, and we'll continue this.